Hi, my name is Carrie Walker, and I will be facilitating the Village's Health presentation on the science of aging. So often we're told to exercise and eat more greens and colorful vegetables. Today we're going to explore why we're being asked to do that and take a look at how our choices of what we do and what we eat and drink affect our bodies on the molecular level. Please keep in mind that the information contained in this presentation is designed for educational purposes only, and it's not intended as a substitute for advice from your healthcare professional. The goal of today is to be able to develop practical strategies to help you live a longer, healthier life free of pain and disease by the following. We're going to be learning about different processes that age our body. We're going to look at what speeds up these or slows down these processes. And also, I'm hoping that you'll gain a better understanding about how lifestyle impacts these processes and what we can do to either prevent or repair damage from these processes that we're going to discuss in the presentation. It's important to better understand the biology of aging because aging is a major risk factor for many chronic diseases. Therefore, if we can slow down or lessen the effects of aging on the body by addressing these mechanisms, we may be able to reduce the incidence of chronic disease, which sounds pretty good. In fact, the CDC has put out figures that estimate that if we were to eliminate risk factors through what we're eating and how often we're exercising, eliminate tobacco and alcohol use, we could reduce our risk factor of heart disease and stroke by 80%, as well as type 2 diabetes, and reduce our risk of cancer by 40% and our risk of dementia by 32%. Those are pretty large figures. So let's get started and see how all these things that we do affect our body on the molecular level. The three different processes we're going to take a look at are 1, oxidative stress, 2, glycation, and 3, inflammation. Now, I want to give you preface this presentation by acknowledging that I'm going to be tackling a little bit more science than maybe you're accustomed to in some of our other presentations, but I'll do my best to break things down into terms we can all understand. Oxidative stress occurs when there's an imbalance between the number of free radicals produced in our body and the amount of antioxidants that we have present. So stay tuned. I'll elaborate and break that down a little further. Glycation is a process by which sugars in our bloodstream bond to proteins such as red blood cells and collagen fibers that ends up stiffening the tissue and destroying their function. Inflammation is a process that we all need to help repair our body and fight infection. However, when you have chronic inflammation, the body's process begins to fight against its own self. Before we start talking about oxidation, which is the first process we're going to look at, we need to take a few steps back to chemistry days and understand an atom. If you can recall, atoms are the basic building blocks of all matter, living and non-living. They are invisible to the naked eye. Atoms, these particles, contain protons, neutrons, and electrons. If you look over to the figure at the right, in the nucleus of the atom, there's a proton and a neutron. The proton has a positive charge. The amount of protons is equaled by the amount of electrons or negative charges, so that the overall charge of the atom is neutral. The positive charges neutralize the negative charges, or vice versa. And that's how atoms stay nice and stable. They have an equal number of electrons and an equal number of protons. Now let's take a look at some of the habits of electrons. Electrons like the buddy system. They don't like to travel alone. So this means that atoms like to have an even number of electrons, so they each have a buddy or a partner to travel with. And when they have an equal number of electrons, this atom stays by itself. It doesn't interact with other atoms. However, through a metabolic process or some type of chemical reaction in our body, oftentimes oxygen molecules will lose one of their electrons. Now, oxygen is needed by almost all parts of our body, so it is everywhere. And oxygen is used in a large number of metabolic reactions that are part of our normal metabolism. So when these oxygen molecules go through this process, whether it's creating an energy molecule from our food or breaking down different proteins in our body, they often lose an electron. Now, when an oxygen molecule loses an electron, it becomes unhappy. And it is desperate to find an additional electron to neutralize itself and to make sure that it has an equal number. So when you lose one electron in a pair, the atom becomes what we call a free radical or a charged particle. So all of these oxygen molecules in our body that have lost one of their electrons are now called free radicals. You may have heard about this when you are listening to some of the commercials talking about the importance of antioxidants, which we'll get to later. So since electrons like to be in pairs, these free radicals start stealing electrons from other cells within our body. And when they steal an electron from a cell in our body, it damages that cell. Now, depending on which cells in our body they're pulling these electrons from, that's where the damage becomes. So as soon as one of these molecules pulls an electron from a neighboring cell, now that cell that it pulled it from becomes damaged. And it creates a chain reaction because now that cell is desperate to become stable, and it will continue pulling an electron from another cell, and so on and so on. The problem with this is when the cells lose their electrons, the cell membranes become damaged, even leading to damage in the DNA or the identity of the cell, which can lead to cancer. So this is a little I have some good news for you. Enter the role of antioxidants. Antioxidants are found in our foods and also made by our body. They are the superheroes because what's different about an antioxidant is an antioxidant can donate an extra electron to neutralize the oxygen molecules, but it doesn't itself become damaged. They are free to give electrons without becoming destabilized themselves, thus reducing the free radical chain reaction. Our bodies normally make antioxidants, but unfortunately not enough to offset this damage caused by free radicals. We need to eat a variety of foods to get more. Well-known antioxidant sources include beta-carotene and other carotenoids, lutein, resveratrol, which is in red wine, vitamin C, vitamin E, selenium, and lycopene. And the good news is all of these are found in the foods that we can eat. Oxidative stress, getting back to the different processes in our body, oxidative stress occurs when there are more free radicals than antioxidants available in our body. And the damage from these to cell membranes starts to become unchecked. Left unchecked, it leads to inflammation in cells. Here's a picture of why. I want you to remember this picture of why free radicals are so dangerous. A normal cell minding its own business on the left side of the slide becomes a target of free radicals attacking its cell membranes, wanting to pull electrons from it. As you can see, the cell is starting to change. Now, keep in mind that our entire body has cells. So depending on whether these cells are in our heart, our liver, our brain, that's where the damage is going to occur. As you can see on the right-hand side of the slide, this cell does not look too happy. And this process, this oxidative stress, is what is largely responsible for a lot of the disease of tissues in our body. Conditions linked to this oxidative stress have to do with the stress damaging either the cell membranes of the cells in our body, the proteins in our body, like such as collagen and elastin in joints, and also damaging the very DNA of our cells, which gives it the direction and instructions about what each cell in our body is supposed to do. Oxidative stress usually goes hand in hand with chronic inflammation. Because of all these free radicals are running around our body, they are triggering our body's natural immune response. Our immune system wants to neutralize the damage, so it sends out chemical messengers. Some inflammation, as we'll see in a few slides up, is okay, and it's used to fight our body's natural viruses that enter it, or toxins, or wounds. However, left unchecked, chronic inflammation can lead to cancer because the DNA in the cells are becoming damaged, arthritis, if the oxidative stress is in your joints. It can also lead to cardiovascular conditions, as I always have a difficult time with this, atherosclerosis and high blood pressure, because the free radicals trigger a buildup of plaque in your blood vessels, which lead to higher cholesterol or hardening of the arteries. Our brains require a large amount of oxygen to function, so it's not unusual for free radicals of the oxygen molecules to be floating in our brain. However, if there's too many and we don't have enough antioxidants to neutralize them in our brain, the oxidative stress is now being linked to neurodegenerative diseases such as Alzheimer's or Parkinson's. Strategies to reduce oxidative stress involve eating a balanced, healthy diet rich in fruits and vegetables. Fruits and vegetables with various colors will guarantee that you're getting a nice variety of the different type of antioxidants. You want to limit your intake of processed foods, particularly those high in sugars and fats, as well as preservatives, because those types of foods can also trigger the free radicals and oxidative damage themselves. Regular exercise has been known to help regulate the damage of free radicals and also to trigger the production of more antioxidants naturally in our body. Maintaining a healthy body weight is important because we now understand that adipose tissue or fat cells also have a signaling system that can trigger inflammation, which also triggers oxidative damage. Everything is starting to become interrelated, you've probably noticed. The processing of alcohol in our body can trigger free radicals, raise blood pressure, and also create oxidative damage. So you also want to avoid or reduce exposure to pollution and harsh chemicals, because those can also introduce more free radicals to our body, which will cause damage to our cells, as we just heard. Here's a look at some of the foods that are high in antioxidants, the top 20 foods. You see a nice variety here, noting that they're all various colors, and that's why you may have heard people encourage you to eat the colors of the rainbow. Beans are an excellent source of antioxidants. Cranberries, strawberries, apples, artichokes, blueberries, plums, raspberries, berries in particular are very high in antioxidants. So you want to do some meal planning and take a look and see how you might be able to introduce more of these foods into your meals. Putting a handful of berries on a salad is a great way to boost the antioxidant total. or throwing berries into your oatmeal is also another way you can just up the antioxidant intake without really drastically changing your menu plan. Glycation is the next process that we're going to take a look at and how it ages our body. Glycation occurs when the body's proteins react with sugar molecules in our body, permanently damaging their initial function. Our body digests carbohydrates into building blocks called glucose. Glucose molecules are needed for the manufacture of energy molecules in our body. But when our body has too much blood sugar, particularly if you're diabetic, the extra glucose molecules, or the sugar molecules in your blood, will start binding to hemoglobin molecules. They can also bind to collagen in your skin, which can lead to aging. The reason I have a picture of hamburgers here is this is an illustration of glycation. The sugar in the meat has interacted with the protein in the meat, creating that nice crust that we love on our hamburgers. However, it is a result of glycation, and this is what happens in our bodies when the sugar molecules react with the protein. It permanently changes the cell structure, not allowing it to perform its normal function. When sugar reacts with proteins or other molecules in our body and permanently bond to them, they can they create damage in tendons, bones, and cartilage, resulting in inflammation and oxidative stress. AGE stand for Advanced Glycation End Products. That is what is formed when a sugar molecule permanently bonds with protein or a fat. The problem is, once it damages that protein or fat, whatever the function of that protein or fat was, it can no longer be performed. AGEs can also form in foods, as we saw. Foods that have been exposed to high temperatures, such as during grilling, frying, or toasting, tend to be very high in these compounds. AGEs are made in the body. However, diet is the biggest contributor of AGEs. In the body, glycation causes tissues to become harder, thicker, and less pliable. Some of the areas of damage are listed on this slide. Cataracts, the lens covering our eye becomes cloudy and thicker until vision can become impeded. Think of an egg white. The egg white starts out clear when the egg is raw, but as it cooks, the protein becomes damaged in the egg or becomes glycated, so it's no longer clear. This is what happens to the lens of our eye when we start needing cataract surgery. When the sugar molecules bond to the sides of proteins in our blood vessels, it can lead to the hardening of the arteries. It can also damage to the blood vessels in our kidneys, and it can also cause loss of muscle flexibility as the muscle fibers become more hard. Here's an illustration of how the sugar or glucose molecules in our bloodstream bond to the hemoglobin molecule. Hemoglobin is the carrier molecule that brings oxygen to all the different cells. Your A1C rating or number is the percentage of hemoglobin molecules in your bloodstream that have become glycated. Unfortunately, if too many of the hemoglobin molecules become glycated, it can interfere with your body's ability to transport oxygen, leading to oxygen-deprived cells, which is extremely problematic in the brain. Sugar also ages your skin. Behind sun damage, sugar is the number 2 factor in aging of our skin. Excess molecules of sugar in our bloodstream end up bonding to proteins in our skin, such as collagen and elastin, permanently damaging it, causing dryness. As you see on the left-hand side of the screen on the bottom, those our health, in our healthy skin, those cross linkage are the collagen and elastin fibers. As you see, they hold up the epidermis, which is the surface of our skin, in a nice, strong, firm foundation. However, when skin becomes glycated, those glucose molecules begin bonding to the collagen and elastin, damaging it, creating a wrinkle. Remember that there's many forms of sugar. Just because you're limiting your processed intake of processed sugar, such as candy, cookies, and sweet, doesn't mean that you're not still consuming too much sugar in your diet. Read your labels. As you can see here, all of these things here, whether it's peanut butter or even the beans or some of our condiments, particularly ketchup and mustard, can be contain hidden forms of sugar. Remember too that eating too many carbohydrates, such as in breads and pasta, can also lead to an increase in blood sugar because carbohydrates are metabolized and broken down into glucose molecules, further driving up your blood sugar. Glycation, the process when the sugar molecule bonds to either the protein or the red blood cell, occurs when there's spikes in your blood sugar. Certain foods will encourage that spiking. So the goal is to eat foods that are lower on the glycemic index. The lower of these foods, the foods that you eat rate on the glycemic index, the less likely they are to create a blood sugar spike. So the goal would be to try to incorporate more foods in the lower end of the glycemic index. Foods that are high in AGEs are typically your foods that have been cooked at higher temperatures, but they also include foods that are higher in full fat dairy, processed foods. So let's take a look here. If you want to have an egg for breakfast, if you have a fried egg for breakfast, it contains 1,240 kilometric units per liter. The goal is to limit yourself around 15,000 per day. But you can see by just making a simple switch of scrambling the egg, it goes from 1,200 down to 75. Simply toasting your bagel versus having it plain and untoasted is a difference of 40. Using whole milk cream cheese versus, using whole milk, a cup of whole milk has nearly a quarter less. Let's see, I'm getting lost here. You can see the difference of grilled chicken versus poached chicken, significantly less of the AGEs, simply by changing the method of your food production. So remember, your body will take care of and process some of the AGEs naturally that are formed, but by increasing your intake through food, through processed foods, and also foods that are cooked at higher temperatures, it upsets the balance. And AGEs can also trigger your inflammation in your body. So tips to reduce the amount of AGEs or advanced glycation end products in your body. You want to do that by reducing your sugar intake. Pure and simple. If you limit the amount of processed sugars that coming into your body, you're limiting the likelihood that it's going to bond to different cells in your body in the protein and the fats. Exercise is a great way to reduce advanced glycation end products because exercise is the one process that you can do in which your cells will uptake more sugar rapidly from your bloodstream without the use of insulin. Choosing different cooking techniques, as we saw, will greatly reduce the amount that you ingest. And also eating a diet high in antioxidant-rich foods will help some of the inflammation that's triggered by the AGEs. So hopefully you're keeping up with me. Both oxidative stress and the glycation process, which produces the AGEs, lead to inflammation. Inflammation, when we talk about it, it's important to differentiate between acute versus chronic. Because inflammation was initially meant to help our bodies. Acute inflammation is how your body fights infection and helps speed up the healing process. In this way, inflammation is good because it protects the body. This process works the same if you have a virus like a cold or a flu. In contrast, when inflammation gets turned up too high and lingers for a long time, either because it's driven by a lot of free radical damage from the oxidative stress, or you've got too many of those AGEs floating around in your body and too much damaged cell proteins because of the AGEs, the immune system continues to pump out white blood cells and chemical messengers that prolong the process, causing what's called chronic inflammation. From the body's perspective, it's under constant attack, so the immune system keeps fighting indefinitely, eventually fighting against itself. When this happens, white blood cells may end up attacking nearby healthy tissues and organs. For example, if you are overweight and have more fat cells, the deep type of fat that surrounds your organs, the immune system may see these cells as a threat and attack them with the white blood cells. The longer you are overweight, the longer your body can remain in a state of inflammation. Research now shows that chronic inflammation is associated with heart disease, diabetes, cancer, arthritis, and Crohn's disease. This slide goes into a little more in depth about how inflammation in different types of body, different parts of your body will trigger different chronic conditions. Again, there's some very good news. There is a way to help reduce much of this chronic inflammation. Keep on top of your dental health. Bacteria produced in the mouth through a cavity or an infection can enter the bloodstream through your mouth and travel to different parts of the body. When it lodges in different blood vessels, it can trigger the production of more plaque buildup in your vessels. The plaque buildup in your blood vessels will then trigger more inflammation because your body's trying to fight that plaque buildup. Maintaining a healthy body weight is important because we now understand that fat tissue is not inert. It actually signals an inflammatory response. So you want to reduce the amount of fat that you have so you don't get that inflammatory response. As a person becomes increasingly overweight or obese, the fat cells actually can crush each other because of the extra weight, and that crushing or damaging of the adipose tissue creates more inflammation and more damage. Exercise is a wonderful way to uptake more glucose from your blood system so that it's not bonding causing AGEs, which in turn triggering more inflammatory response. Processed foods and any foods with saturated fat or trans fat will increase inflammation in your body. And as we saw, inflammation is behind a large majority of chronic disease. Alcohol breaks down into different sugars, which are toxic to the body and also increase inflammation. So the important thing is to try to think back to the previous slide and incorporate as many antioxidant high-rich foods that you can. Here's another picture of giving you some ideas. So in order to reduce our risk of chronic disease, we want to break the cycle. Slowing the aging process is accomplished by doing things that inhibit and repair the damage from these aging mechanisms, or at least slow the rate at which the damage is done. We saw how both the oxidation and glycation process can trigger chronic inflammation. And now we understand that chronic inflammation is behind many of the chronic disease processes because the body is beginning to it's fighting against itself. Chronic inflammation can trigger the production of more free radicals, which in turn leads to more oxidative damage. Glycation can also trigger oxidative stress. So really, at the end of the day, understanding how we can make changes in our diet to limit these processes is extremely important. Let's take a little quiz to make sure that we've digested all this information. True or false? Free radicals are a normal part of our metabolism. The answer is true. Exercise is one such process that produces free radicals. The metabolism of food, of getting energy from our food, is another form. And in fact, free radicals are necessary to balance our homeostasis or the maintenance of certain conditions in our body. The problem occurs when there's too many. So number two, a large amount of free radicals in our body is a good thing. False. As I said, some are good, but if we upset the balance, we start getting oxidative damage, which can trigger inflammation. Number three, when I eat sugar, it's simply digested and eliminated as waste from my body, so therefore it's not causing any harm. The answer is false. Sugar triggers that inflammatory response. Excess sugar in our bloodstream can also begin to bond to proteins and the red blood cells, causing damage. Number four, eating sugar helps me look younger. Well, as we saw in the one slide with glycation, the answer is false. Sugar bonds to the collagen and elastin fibers in our skin, causing wrinkles. Number five, inflammation has been linked to many chronic health conditions. This is true. Number six, what I eat has nothing to do with my risk for chronic disease. And this is where I would really like to end the presentation, because the fact is now hopefully I've provided some more information that will give you cause to pause when you are doing your meal planning. Because the good news is what we can do there's so much that we can do to limit the occurrence of an impact of oxidative stress, glycation, and inflammation in our bodies. The biggest is by reducing our intake of sugar. This will make sure that our blood sugar levels stay consistent and we don't have that extra sugar roaming around in our system looking to attach to protein molecules or red blood cells. Exercise helps us maintain a healthy weight. Science now shows that extra body weight triggers inflammation. Fat cells are not stationary, docile cells doing nothing. They trigger inflammation, causing a whole host of other problems. We can choose different cooking techniques that limit the amount of char or damage to the protein in our meats that we eat. Limiting foods high in advanced glycation products are helpful. We can neutralize a lot of the damage in our bodies by eating a diet high in antioxidant-rich foods. Before you embark on a quest to incorporate a lot of antioxidant-rich foods, do check with your doctor to make sure that particular antioxidants are not going to interfere with certain medications you may be taking. Our bodies best absorb antioxidants from our food. Supplements don't necessarily, we take over the counter, don't necessarily provide the same benefit, such as fueling your body directly from food sources. I hope you've enjoyed this and have come away a little bit more enlightened and feeling empowered that the choices we make in terms of the food we eat can greatly impact how our body ages. And if we can reduce the effect or slow down the effect of from these processes of aging on our body, there's a good chance we might also be able to mitigate the onset of chronic disease. Thank you for listening, and if you have any questions, please reach out to the Villages Health Learning Center.